Today we are doing section 1.6, angles and their measures. We are going to use angles and their measures. This is our last section for chapter 1. If we are looking at ray PQ, the end point of that would be point P. Remember on a ray, the order that we write it in matters. Line segments with the same length are called congruent. A pair of opposite rays would form a line. Very good. A rule of geometry that is accepted without justification is called a... That's one of our first vocab words. A postulate. Very good. Our first vocab word, angles, or an angle. Two rays with a common endpoint is what forms an angle. So we have an endpoint. We have a ray going off one direction, another ray going in another direction. That is how we form an angle. Those rays also usually have their other points marked on them. So this whole thing represents an angle. I'm going to go ahead and label all of my points. I will call them A, B, and C. We are going to refer back to this diagram for most of the vocab words on this slide. We can name an angle a couple different ways. We use a little angle symbol. It almost looks like a less than symbol from algebra. And we name it by the points. You start at one end and you work your way to the other. So we could name it angle A, B, C. We have to use 3 points most of the time. This is how to name an angle. We could go the other direction. So we could start over here at point C and go to B, then A, and call it CBA. Or, because there's only one angle drawn there, we can just name it by the middle point B, that common endpoint. We can call it angle B, but I would be careful about using this because you can no longer use that method when we split that angle. So like if we were to put in another ray somewhere else in there, you could no longer call that angle B, because we've got too many angles going on. If you only have one angle, then it's fine. The last way you'll see angles named would be if we put a number inside of it, like a 4. Then it could also be referred to as angle 4. Any 4 of those ways works. Keep in mind 4 is not a degree measure, it's just a number that we're giving to name that angle. Lots of ways to name angles. The sides, again, I'm going to refer back to this same diagram. The sides are the 2 rays that form the angle. So we would name sides just like we would name rays. One of those rays is ray BA. So just like we did a couple lessons ago, we use the little ray over the top and the 2 points underneath, starting with the end point going to the other point. We also have ray BC. Again, we start with the end point, we go to the other point. So this is how to name. We're still referring to the same diagram. The vertex is the common endpoint of the angle. So in this case, the vertex is point B. We name it just like we would name any other point, just that letter. The measure of an angle is written in degrees. There's not really a drawing for that other than to show an angle. Sometimes you'll just see the degree measure written inside of it. So sometimes you would see it like 91 degrees. And that's just how we would name it. We could say the measure of, I guess that would be more appropriate, the measure of angle ABC is equal to 91 degrees. You'll see the little M out in front of the angle symbol when we're talking about its measure. Last but not least on this slide, we have congruent angles, which are two angles with the same measure. So your drawing for that, your diagram could just be two different angles that have the same measure. So you could, oh, I should not have drawn that one all the way down there. Let's move it up. So mine might not be perfect, but if I say that this one is 35 degrees and that this one is also 35 degrees, I could say that they are congruent. The rest of our vocab words all describe types of angles. Again, I would be surprised if you hadn't heard of any of these before. An acute angle is an angle that measures between 0 and 90 degrees. So your diagram should just be any angle that measures less than 90 degrees. You can label it if you would like to. You can put a degree measure in there if you would like to, as long as that degree measure is between 0 and 90. We would name it just like we would name any other angle. So we could call this one angle A since there's only one angle drawn there. A right angle is an angle that measures exactly 90 degrees. So that one should look most of the time like a capital L. But it could be flipped around in a different orientation. So it could be turned or something like that, right? But usually on a right angle, you won't see 90 degrees written there. You will see this little box in the corner. I would include that on your diagram. That indicates that it is a right angle. And again, we would name it just like we would any other angle. We just refer to it as a right angle. So we would call that angle X, Y, Z. The important part on these is more the diagram, including that little box for a right angle. An obtuse angle measures between 90 degrees and 180 degrees. So it could look something like this. Again, named just like any other angle would be named. And would have some degree measure that is between 90 and 180. So 163 would work. We'd call that angle LMN. Finally, a straight angle is just a straight line. It measures exactly 180 degrees. Technically, we would still name it like other angles. It's just that the points are all collinear. So let's do CDE. So we would call that angle CDE. You could also call that a line. You could name it as line CE, line CD. But if we're referring to it as an angle, it's just a straight angle. And again, the measure of it is 180 degrees. Okay, so we have named the vertex of this angle point B, the sides of the angle ray BA and ray BC. Finally, we need the names for the angle, which in this case we have 3 different names we could give it. Can anybody give me one of the names? Someone I haven't heard from yet today. What was that?
Angle ABC.
Wonderful. Angle ABC. Connor, did you have another one?
I got confused.
Oh, okay. Anybody else have another one? John? Angle CBA. And the last one, which is not my preferred one, but you will see it sometimes, is just to write angle B, because there's only one angle there, so it's allowed. The rules change when there's more than one angle present. So the question is, why are angle EDF, angle D, and angle EFD all incorrect for naming this angle? Connor, what do you think?
I'm looking at it right. They switched around the middle. So they switched around E and D. D should be at the front, and E should be in the middle. It should be angle B, and at the end, F should be where E is.
Okay, so they have the ordering wrong on all of them. We could sum it up by saying that E is the vertex. Point E is the vertex. If point E is our vertex, then if we're naming it with a single letter, it should be with letter E. And when we are naming it in order, either backwards or forwards, E should always end up in the middle. How many angles are there in this diagram? What do we think? 3, 4. Interesting. 2, 1. So let's name them and see if we can figure it out. Give me the name of an angle you see. Nikitra.
PQS.
PQS would be an angle. Okay, so that would be this angle here, PQS. That's an angle. Somebody else give me another one. Brandon. PQR is also an angle. We'll do a different color. So PQR is that one out there. Do we have any other angles? John? RQS is another one. So angle RQS. Are there any other angles there we have not named? So if those are all of the angles present, how many did we have? 3 of them. Nikitra?
They are both right angles.
I like it. They are both right angles. Is there anything else we could say? If they're both right angles, what is the measure of each of them? 90. And if they have the same measure, we would say that they are congruent. So we could also say that they are congruent. Okay, on example 5, we are determining if the angles are acute, obtuse, right, or straight. It will only be one of those at a time. So, if we see a measure of 42 degrees, we would say that it is classified as acute. 180 degrees is classified as a straight angle, because it makes a straight line. 112 degrees would be obtuse. And 90 degrees would be right. Wonderful. All right. E. What does that look like? What kind of angle? A straight angle. What about F? It looks obtuse to me. G is right. We know that because of the box. And H would be acute. All right, our postulate for today is the angle addition postulate. If point P is in the interior of this angle RST, then if we take the measure of angle RSP and add it to the measure of angle PST, we should get the measure of angle RST. It's much like the addition postulate we did with the segments earlier this week. On number 6A, we are looking for the measure of angle ABC. How would we find it? Wonderful. Add the addition postulate. All of these are great answers. What are we adding together?
ABD and DBC.
Very good. We are adding angles ABD and DBC together. What do we get as our total? 80. So we should write that the measure of angle ABC is equal to 80 degrees. On part B, what do we get? Very good. It's very similar to the first one. We add them together. So the measure of angle ABC equals 130 degrees. Finally, on C, it's a little bit different. This big arc that I made through the angle refers to the whole thing measuring 135. And just this piece of it measures 60. That's what this means. So how are we going to find the measure of angle ABC? Connor?
Subtract 60 from 135.
Very good. We would have to subtract. And what do we get for the measure of angle ABC? 75 degrees.